a discrete domain, right? And number 4 is what kind of domain? It's continuous, yep. It's continuous, okay? So if we're looking for discrete, we're just gonna list our x values and my y values. So Greg, what is this coordinate right here at the bottom? What is this coordinate right here? This one right here, this bottom one. So we go left, how many? 2, and we go down.
3.
Is that different on mine than yours? I have down -2. You have down -2? Okay. All right. That's okay. I'm like, just making sure they're the same. All right. So our coordinate for that is -2, -2. So my domain for that coordinate would be -2, and my range would be -2. Good. All right. The next point to the right of that would be where, Maxwell? Okay, close. There you go. -1, 0. So what would be my domain for -1, 0? -1, and my range would be 0. Good. All right. See, Jeremiah, what's this coordinate up here? Good, 0, 2. So my domain would be 0, and my range would be 2. Good. All right. Jillian, what's this point to the right? Close. Remember, you go left to right first, so it would be 1, 0. Okay. So what's my domain? 1, and my range? 0. Good. Now, I already had 0 listed, so do I need to list it again? No. So we can go ahead and erase this 0 here. Maybe. There we go. Maybe. Maybe it's not going to erase, but I don't need to have that 0. We'll just keep going. All right, and then what about my last point? Braden. What is this last one? The farthest one to the right. On the first one, we're still on number 1. This yellow point right here. 2, -2. Good. All right, so what would be my domain? The 2 or the -2? Okay. Domain is my x. So the +2. And then the -2 is my range. And we've already listed it. So do I need to list it again? No. Okay. So make sure, guys, when you're doing points, it's always x, y. So you always go left or right first, then up or down. Okay. All right. Any questions with that one? All right. Number 4. This one is continuous. All right. And if it's continuous, we always write inequality signs, right? And again, domain represents the x, and my range represents the y. And then what inequality signs do I always use? Less than. Now, here's the question. Before we did less than or equal to, are we going to keep less than or equal to, or is it just going to be less than? Just less than. Why? Why are we not going to include the equal to? Because they're open circles. Exactly. They're open circles. Now, remember, my domain is the x values. What axis is the x? Is that the horizontal or the vertical? The horizontal. So we're going to go from the farthest point to the left to the farthest point to the right, right? So my farthest point to the left is here at what number? 2. And then we're going to go all the way to the farthest one to the right, which is at what? 7. So my domain is between 2 and 7. And then for my range is my y values. And what axis is my y values? The vertical. So we're going to go to the lowest to the highest. So my lowest point is where? At 1. And the highest point is at what? 6. Okay. All right. Does that make sense to you guys? Yeah. Okay. Phones away, please. Thank you. Okay. All right. Determine whether the graph, table, or an equation is a linear or nonlinear function. Explain. What's linear again? Straight line or constant rate of change. Nonlinear means not a straight line and not a constant rate of change. Also, linear is what equation? Remember, that could be y equals like mx plus b, right? Y equals that mx plus b. Hi, Nolan. We're going over some bell work over 3.4 here, okay? All right, so number 2, James, is that linear or nonlinear? Linear, why? Right, it's a straight line. Perfect. All right. Number 3, we need to see if it's a constant rate of change. So, Will, what are my x's going up by? 1. Each point, is it up by 1? Yep. What about my y's? They're each going up by 2 by every single one. So is this linear or nonlinear? This is linear. Why? That would be for a function. Okay, so how do we tell if this one's linear? What is this called? It's a constant rate of change, yeah. So if it asks for a function, yes or no, that's when you look at the x values, okay? For linear, nonlinear, we look at it, is it a constant rate of change, okay? All right, now 5 and 6 are equations here, okay? So let's kind of look at this. We need to see if it's going to fit y equals mx plus b, meaning there's nothing weird with x's and nothing weird with y, right? It's being multiplied. All right, so if I go to distribute this, what's 4x times 8? 32x. And what's 4x times x? 4x to the second power, isn't it? So does this fit the form of y equals mx plus b? No. So is this linear or nonlinear? This is nonlinear. Why? Because we have this, the x squared. This is actually a quadratic. It's nonlinear. It's a quadratic function. Okay. All right. What about number 6 here? What would I do first here to see if it fits that form? Can I still distribute? Yeah. What's 1/2 times x? 1/2 x. And what's 1/2 of 4? 2. Is there anything weird happening to the x and the y's? No. So would this be linear or nonlinear? So be linear, right? Because again, it still fits in that form of y equals mx plus b. Okay. Because could I add this 4 to the other side? Yeah. So would it fit that form then? Yeah. Okay. All right. Is there any questions on this? Okay. Mason, welcome too. Mason, Nolan, Avery, Bryson, Emma, Cassidy, do you guys have any questions on this so far?
No.
No. Okay.
No.
All right. Thank you. Is there any questions from homework problems that we did? Those that did it. Remember 3.1 and then 3.2, we need to work on those story problems again. Okay, real quick. All right, so I'm going to go ahead and pull up that 3.2 here. Okay. So remember when we talked about the domain being discrete or continuous? Remember, discrete meant it's just random points. We can only have one of something, right? Whereas continuous means we can include all the values between 1 and 2, right? And ask yourself, can you eat a half of a bar? Yeah. So that would be continuous because I can go eat half of a granola bar and be done with it, right? If you really wanted to. You don't like it, you throw it away. You just didn't have time. So when it's asking, is it discrete or continuous, look at it as, can I do a half of something? Okay. And then graph. Do you think you guys could graph this? This is not responding. Could you guys find out values of this? Yeah, if we wanted, right? If I eat one bar, could you guys tell me how many calories I had? Yeah, how many calories would I have eaten? I know. How many calories would I have had? 130. So could I graph the point 1, 130? Yeah, hopefully. If I have 2 bars, how many calories would I eat? Huh? 260, right? Because 130 plus 130. If I have 3 bars, how many could you eat? 390. So could I draw a line between all of those points? Yeah. Okay. Now, the other one I want to look at, this first one, that for some reason, I don't know what happened there. But it says a linear function of y equals 1.95x represents the cost y in dollars of X tickets for a museum. Okay. All right. Each customer can buy a max of 4 tickets. Okay. So obviously we know this is linear because doesn't it state that it's linear? Yes. Okay. Now, is this going to be continuous or discrete? So let's look at it. What does my X represent again? What does my X represent? The number of tickets in a museum. So to be continuous, we have to ask ourselves, can I buy a half of a ticket? No, I can't buy a half of a ticket. I could buy 1 ticket. I could buy 2 tickets. I could buy 3 tickets. I could buy 4 tickets. Can I buy 5 tickets? No, why not? Because we have a max of 4. Can I buy 0 tickets? Yeah, I don't have to go if I don't really want to. So this is discrete, again, because we cannot buy a half of a ticket, right? So it's discrete because you can't buy a half of a ticket. And then how many tickets could I actually buy? So what is my actual domain? I could buy how many tickets? 4. What else could I buy? 3, 1, 2, and 0. So my domain could be 0, 1, 2, 3, and 4. Now, could I find my range if I really wanted to? Yes, I could. Why? Because did they give me an equation? And could I plug my X values in and find my Y values? Yeah. Okay. I don't really feel like doing it. No. Okay. But does that make sense to you guys? The difference between discrete and continuous. Can you buy a half of something? Can you do a half of something? That will always be continuous if you say yes. If you say no, it's always discrete. Okay. All right. So that was the rest of 3.2. Any questions with that? Or you guys feel comfortable with that? You think you're good? All right. 3.3 now. All right. Function notation. All right. For some reason, people always screw up function notation. Okay. And I'm going to try to make it as easy as possible for you. Okay. Normally, you guys see equations of y equals like 2x plus 3. Y equals 5x plus 3. Function notation, it changes the y and just puts f of x. So f of x equals mx plus b. That's it. So anytime you guys see f of x, make it easy on yourself. What does f of x represent? y. So if you see f of x equals like 7x minus 4, just replace f of x with y. That's it, okay? So f of x is the function notation. It's the function of x, okay? So now, if it says evaluate f of x equals negative 4x plus 7 when x equals 2 and x equals negative 2. Well, what's evaluate mean, guys? Just plug it in and solve it, right? And when I see f of x equals negative 4x plus 7, what do? What's f of x mean? Y. So I just rewrite this myself as y equals negative 4x plus 7. Okay? Then it says evaluate when x is 2 and x is negative 2. So 2 and negative 2 are going to go into what variable? X. That's it. Okay? So then this would read y equals negative 4 times 2 plus 7. And can we go ahead and solve? Yeah. So what's negative 4 times 2? Negative 8. And negative 8 plus 7 is negative 1. So y equals negative 1 when x equals what? 2. Okay. Now, function notation will say, okay, remember it's f of x, right? So f of, what do we plug in for x? What do we plug in for x there? 2 equals, what did we get when we evaluated it? Negative 1. That's all that means, okay? So f of 2, so that means x is 2, y is negative 1. That's all that means, guys. Yes, ma'am. We're going to do that now. Yeah, I just did the first one. All right, so now let's go ahead and do the next one, okay? So x equals negative 2. So when we're looking at negative 2, y equals negative 4 times x plus 7. So what are we replacing x with this time? Negative 2. So what's a negative 4 times a negative 2? Positive 8. And positive 8 plus 7 is 15. So y is 15 when x is negative 2. So in function notation, guys, all that means is f of x equals y, right? Well, what was my x? Negative 2 equals, and what is my y? 15. So if you see that, that's all that means. My x is negative 2, and my y is 15. That's all that means there, okay? All right. Could you guys do b now? Now that instead of using f of x, they use g of x. But do you think that's going to change anything? No. G of x just means y. So y equals negative x minus 1. Now, how many x values am I going to plug in? 3. So how many y values am I going to have? 3. Yeah. So we have y equals negative x minus 1. And always use parentheses when you're plugging something in. So what am I plugging in the first one? Negative 4, right? Okay. So a negative and a negative make a positive. And what's 4 minus 1? 3. So y equals 3, right? So instead of f of x, we have g of x equals, what's my x? What was my x that I plugged in? Negative 4 equals, what's my y? 3. So this is g of x equals y. So I just plugged in the x and plugged in the y. Okay? So on your test, I'm okay if you just say y is 3. Okay? But just know if you're using actual function notation, this is what it would read. Okay? All right, what's the next one I got to do? 0. So y equals negative x minus 1. And what's going in? What did you just say? 0. What's a negative 0? 0. 0 minus 1? Not 1, but negative 1, right? Okay. So g of what? 0 equals negative 1. Good. So I think on your online activity, it will say g of 0. You have to plug in the negative 1. Okay. All right, and then the last one here. X is 3. So y equals negative x minus 1. And what's my new x? 3. So what's a negative 3? Negative 3. Minus 1? Negative 3 minus 1 is? Negative 4. So what does this mean? G of 3 equals negative 4. And there you go. Okay. All right, any questions with that so far? Okay. I'm going to skip example 2 for a second because that's the hardest thing, okay? Oops, don't touch. All right, so I'm going to skip example 2, but let's go to example 3 because it's kind of the same idea, okay? For h of x equals 2/3 x minus 5. Well, what's h of x represent? Y. So we have y equals 2/3 x minus 5. Find x for which, what's h of x mean again? Y equals negative 7. Okay. So what are we trying to find here? X, and what is given to us? We're given our y. So that negative 7 now is not going to go in for x, it's going in for y. So negative 7 equals 2/3 x minus 5. Now, solving for x, right? I always move the constant first. How do I move that minus 5? I would add 5, right? What's negative 7 plus 5? Negative 2 equals, now 2/3 x, isn't it the same thing as 2x over 3? How would I get rid of that 3? Multiply it, right? And what's 3 times negative 2? Negative 6 equals, what happens to these 3's? They cancel out, and then I'm left with 2x. And now how do I get rid of that 2? Divide by 2. So x equals negative 3. So x equals 3 when y equals negative 7, right? Okay. Any questions with that one? All right, go ahead and do B on your own here. And do B. Is everyone at home doing okay?
Yeah.
Okay, thank you.
Yeah, I'm good.
Yeah. Thanks, guys. All right, g of x equals what? Y. So y equals negative 2x plus 3. And we're finding x for which what? G of X or Y equals -4. So this -4 is going to go into what variable? Y. So we're going to have -4 equals -2x plus 3. Now, what would be the first step to solve for x? Subtract the 3, good. So what's -7 minus 3? I said this so wrong, didn't I? -4 minus 3? -7 equals -2x. And then how do I get rid of the -2? Divide it. And can I divide -7 by -2? No, but two negatives make a positive. So we have x equals 7 over 2 when y is -4. Okay. All right, any questions with that so far? All right. Now we're going to graph using a t-table. Do you guys know what a t-table is? It's a table that has our x values and our y values. Okay. Now, real quick here. What kind of function is this? Is this linear or nonlinear? Well, what's f of x mean again? Y. So this is just y equals 2x plus 5. Is that linear or nonlinear? This is linear, isn't it? So since this is linear, we are going to have a straight line, right? Okay. So when we make a t-table, we're going to pick 3 values for x. Any 3 values, it doesn't matter. But one thing I'm going to tell you, these are both positive. So your numbers can get bigger the more positives you use, right? Or the higher numbers you use. Okay. So give me 3 numbers for x. Any 3 numbers, doesn't matter. 1, 2, 3. Okay, that would work. The bigger we get, the bigger my graph's going to have to draw, right? So I might choose some smaller numbers, such as, what's a really small number? 0 would be a good one. I like 0. 1 sounds good. 2 sounds good too. Or could you use -1? Yeah, it doesn't matter, but we'll go 0, 1, 2. I try to always choose 0 anytime because 0 is easy to multiply by or add to, right? Okay, so now, since these are my x values, do I know how to plug x values in and find my y values? Yeah, so let's go ahead and do that. So y equals 2 times, what's my first x? 0 plus 5. So what's 2 times 0? 0, and 0 plus 5? 5. Huh? Okay. So now, could I graph the point 0, 5? Yeah, that means I would go left or right, 0, and up 5. So 1, 2, 3, 4, 5. It's right there. All right, let's plug in 1 now. Y equals 2 times, what's my x? 1 plus 5. So what's 2 times 1? 2. 2 plus 5? 7. So how do I graph the point 1, 7? Right 1, up 7, 6, 7. So I have that. All right, now if I plug in 2, what's going to happen to my graph? It's going to be a lot bigger than my actual graph. So let's pick a different number. Give me another number to choose for. You really want to multiply by 1 and 1/2. How about a -1? Is that okay? Thanks. You're picking some crazy numbers here. All right, so 2 times -1 plus 5. So what's 2 times -1? -2, and what's -2 plus 5? 3. That makes more sense, doesn't it? Because now it's in my graph. So how do I graph -1, 3? Left 1 and up 3. There you go. Now, can you draw a line? Yep. Make sure we always have arrows. Why do we have to have arrows on our lines? Because it's going to keep on going. It's continuous, right? Nonstop. All right. All right. Now, let's look at B here. Now, it is changed a little bit, right? But f of x still means what? y. So this is just y equals 1/3 x minus 4. Okay? Is this going to be linear or nonlinear? Is there anything happening to x or y? Nope, so it's still linear. Okay. You did. I thought you said nonlinear. I'm like, huh? Okay. All right. Now, if you notice, we're taking 1/3 times x, right? 1/3 is the same thing as dividing by what kind of number? 3, right? Dividing by 3. So can I pick numbers that I can divide by 3? I could. No matter what, what's one number I should always try? 0. 0. Now, remember, we're taking x and timesing it by 1/3. So we want to times numbers that I can divide by 3, right? So give me a number that's divisible by 3. 3. What's another one? 6. Or could I have done -3? I could have done 9. I could have done 27. But 27 is a big graph, isn't it? Yeah. 30. Yes. Yep. Okay, there's tons of numbers we could choose. But just remember, if you're drawing the graphs, do I want to go x all the way out to 30? If you do, you're never going to finish something. All right, so let's plug those in. So y equals 1/3 times, what's my first x? 0. What's anything times 0? 0. 0 minus 4? Close, -4. So how do I graph the point 0, -4? Over 0 and down 4, good. And then let's plug in now 3. So y equals 1/3 times, what's my new x? 3. What's 1/3 of 3? 1. 1 minus 4, -3. Good. So can I go right 3, down 3? Yes. Okay. And then my last one, y equals 1/3 times, what's my x? 6. Okay, so what's 1/3 of 6? What's 6 divided by 3? 2. And 2 minus 4? -2. So can I go right 6, down 2? Yeah. And I can draw my line. Now, real quick, what would be the next? Let's see this. What would be my next x? If I did 0, 3, 6, what would be the next one? 9. And could anyone tell me without plugging in what my y value would be? -1. If I went backwards from 0 would be what? -3, right? So what would be my y value? -5. So if it's linear, there should be a pattern between your x's and your y's because it's a constant rate of change. Yeah. Okay. Is there any questions with that? All right. So now I'm going to go to example 2. We're going to finish here and then we'll probably stop for the day so you guys can just worry about that. Okay. All right. So let F of T be the outside temperature in Fahrenheit. What's F of T mean again? Y. All right. So my Y represents the outside temp. Okay. You guys okay with that? Okay. T hours after 6 a.m. So my X, which is T, is what? Hours after 6 a.m. So let me ask you, if my X is 5, what time is it? If T is 5 or X is 5, what time is it? What's 5 hours after 6 a.m.? 11, right? It'd be 11 a.m. If my T is 12 hours, 12, what time is it? It is 6 p.m. Okay, does that make sense to you guys? Okay, so now what if I ask you, okay, what does F of t equals, actually, let me erase that for a second. F of 2 equals, let's see, what's the temp outside right now? 40. What does f of 2 equal 40 mean? Okay, well, let's kind of think about this real quick, okay? What does this 2 represent? Is that my x or my y? Remember, it's f of, usually x equals what? Y, right? So what does that 2 represent? X. So my x is 2. What's the 40 represent? That's my y, right? Which is 40. So yes. Okay, so now in words, what does this mean? Okay, what does x? X is 2. X represents the hours after 6 a.m. So what time is it when x is 2? 8. So at 8 a.m., what does y represent? Temperature. So at 8 a.m., my temp is what? 40 degrees Fahrenheit, right? Obviously, it's 10:30 right now, but that's what that represents. So what if I say f of 7 equals 23? Okay, what is my x here? My x represents what? 7. My x is 7. So 7 hours after 6 a.m. puts me at, 4 p.m.? No, I don't think so. We're still looking at the 6 a.m. Yeah, sorry. We're still looking at that first one. Sorry. So 7 hours after 6 a.m. would be 1. So at 1, is that a.m. or p.m.? p.m. So at 1 p.m., what's 23 mean? That's my y, right? So my outside temp is 23 degrees Fahrenheit. I said Fahrenheit. Okay. Now, what if I changed this and made it a less than symbol? So at 1 p.m., my temp is going to be less than 23 degrees. That's the only difference. Instead of saying is, it is less than 23 degrees. That's it. Okay. Does that make a little bit of sense to you guys? Okay. What if I said f of 2 equals f of 5? So my temp at what hour? My x is 2, right? So what time would that be? At 8 a.m., the temp is going to equal the temp at what? What's 5 hours after 6 a.m.? At 11 a.m. So f of 2 equals f of 5 means my temp at 8 a.m. is going to be the same as my temp at 11 a.m. Okay. Do we actually know the temperatures though? No, we just know that they're going to be the same. Okay. All right. Does that make sense to you guys a little bit? Do you see why I left this go last? Yeah, because it's kind of weird on that wording situation. I think you have one problem like that. All right. On homework. Okay. So what you guys need to do, okay, your assignments, okay? So remember, 3.1 was due today, right? And I said with 3.2, I wanted to go over. Some of you guys already finished it. I think 16 out of the 29 have finished it. That's great. But we need to finish 3.2 if you have not, or 3.1, and then 3.3, okay? Right now, 3.2 is assigned to you, but I will change those dates. Do not worry about 3.4, okay? This is your homework. It needs to be done by Tuesday, okay? We have a quiz on Tuesday over these 3 lessons. Yes. No, I'm gonna delete that right now on that or change the date for it. Okay? Why is your quiz on Tuesday next week? That is our e-learning day on Tuesday next week, not Wednesday. So your quiz will be over 3.3. Then on Wednesday, you'll be in this classroom, okay? And we'll do the 3.4 and see how much we can get into 3.5. Okay? Huh? No, because I don't want to do an A block all day in class.